In this section, we continue with other performance tips and pitfalls, starting with lists. When we initially created the List API, we were heavily inspired by Swing's architecture. The ability to create an infinitely sized list without performance penalty was attractive and seemed like a good direction for our original 2 MB RAM target devices back in 2006-07. We knew the renderer model approach was hard for developers to perceive, but we also assumed a lot of Swing developers would find it instantly familiar. We made attempts to improve List in the years since, for instance, multi-list, generic list cell renderer, container list, etc. These helped, but the core problem of List remain. I won't go into all of the problems with List and only focus on the fact that performance benefits of List are dubious. List can perform well, but writing performant List code is a challenge. Anything under 5,000 entries would perform better with alternative solutions. If you need more than 5,000 rows, reconsider. Scrolling beyond 1,000 rows on a mobile device is challenging. It made sense for a Swing application, but it doesn't make sense for a mobile phone or even a tablet. Most developers will be better served by an infinite container. If you do choose to go with List, the performance of the renderer and model methods is crucial as they are invoked multiple times per page over and over again. In fact, this is such a problem that for anything under 200 elements, a container would perform much better than List. Overdraw is the process of drawing the same pixel more than once. So if I paint the background in white, then draw text on top of the white background, I've effectively overdrawn every pixel where the text is drawn. This is perfectly normal for an application. For example, I can fill the background in white, then draw text on top of that. However, if we overdraw a pixel 4 times, there might be a problem. That might mean the logic of the application is drawing a background for the root component, then drawing again on top of that, and again. That might still be okay, but we need to be aware of this and minimize it, as overdraw can be expensive. Reducing overdraw can boost rendering performance and animation smoothness. To reduce overdraw, we need to look at the hierarchy in the component inspector and minimize opaque/translucent elements. We want no more than 2 backgrounds per hierarchy under ideal circumstances. I will discuss the process of debugging overdraw later. Networking is usually conducted on its own thread, and for the most part shouldn't impact performance too much, as the network thread yields CPU seamlessly when you use the network manager. However, there are some nuances that should still be followed. By default, Codename 1 allocates 1 thread for networking, so developers can rely on simple consistency when making a request. Otherwise, you might write code like the code above, and request 2 would finish before request 1. That's perfectly fine for some applications, but you need to be aware of that. Assuming you understand this, we recommend 2 network threads for most applications. You can add more, but that might impact overall performance without providing a huge benefit to network speed. You can set the thread count in the init object method in the main class using update network thread count method. The network threads are often the best place to do long-running network-related tasks such as parsing. For instance, the code on top might seem simple, but it carries a price. It runs on the EDT. The code above will work correctly since the UI change will run on the EDT, but the parse data invocation might be slow and might slow the entire UI. A better approach will be the usage of the code below, which runs the parsing on the network thread. This has the added benefit where the response stream isn't read to a byte array first before parsing. Notice that the REST API in Codename 1 implicitly does the parsing of JSON on the network thread to protect the EDT. It's easy to lose track of size/performance when you are working within the comforts of a visual tool like the Codename 1 Designer. When optimizing resource files, you need to keep in mind one thing. It's all about image sizes. Images will take up 95 to 99% of the resource file size. Everything else pales in comparison. Large resource files can both harm your build quota and hurt your performance by taking up too much RAM in runtime. They increase the distribution size, which means users might uninstall your app or even forget they installed it by the time it was downloaded. Like every optimization, the first rule is to reduce the size of the biggest images, which will provide your biggest improvement. For this purpose, we introduced the ability to see image sizes in kilobytes. To launch that feature, use the menu item Image Sizes in the designer. Make sure to back up your resource file on a regular basis, especially before doing this stuff. Unless you found a specific image that takes up most of the space, it's probable that space is taken up by many multi-images. Multi-images are essentially a single image in multiple resolutions for different device densities. These images can grow to a very large size as we store a lot of resolutions for every such image. If there are densities you don't need, such as low, very low, both of which don't exist in smart devices, or 4K, you can just delete all of these images from existing multi-images through the menu item Image, Advanced, Remove DPI. Image Delete Unused Images presents you with a dialog containing the images that are unused in the theme. It allows you to select the images you wish to delete. All are selected by default. Notice that this method doesn't scan the code for image usage, so an image which you refer to from code will be marked as unused, and you would need to unmark it manually. If you have a very large image that is opaque, you might want to consider converting it to JPEG and replacing the built-in PNGs. Notice that JPEGs work on all supported devices and are typically smaller. You can use the excellent OptiPNG tool from http optipng.sourceforge.net to optimize image files right from the Codename 1 designer. To use this feature, you will need to install OptiPNG, then select Images, Launch OptiPNG from the menu. Once you do that, the tool will automatically optimize all your PNGs. When faced with size issues, make sure to check the size of your res file. If your jar file is large, open it with a tool such as 7-zip and sort elements by size. Start reviewing which element justifies the size overhead. Some APIs might impact performance negatively in some cases. Let's start with round border and round rect border. Since their low-level rendering code can be expensive, we use a mutable image to cache the data into the parent component object. This trades off performance for RAM and might cause an upfront performance penalty. Normally, it shouldn't matter if you have a couple of round buttons. However, this could be very costly if you have a list containing many elements with such borders. Gradients used to be very slow in Codename 1 as they relied on software rendering for portability. Newer versions are much faster for the most part, but I would strongly advise benchmarking to make sure. Using a gradient as a background creates an image object background, which can result in a huge memory overhead. You would often be better served with solid colors or image backgrounds. Gaussian blur is an inherently slow algorithm. There is no getting around it. If you need to use this API, you need to use a trick like call serially on idle or a thread. Notice that APIs such as Drop Shadow use Gaussian blur under the hood.